Welcome to the short presentation on wheels. Today we're going to look at the different materials used to make wheels, the different ways the wheels are sized and measured, as well as the tyre valve itself. Before we do that, let's have a quick look at the history of the wheel. Now, ancient people knew about rollers, simply logs put underneath heavy objects. You can think about how the Egyptians moved the large stones to build the pyramids. But these rollers aren't particularly practical or particularly efficient. Think in terms of as a roller rolls out from underneath an object, it's going to have to actually be moved round to the front so you can carry on rolling it. And particularly when cornering, friction can make them very, very difficult to move. So the next step on from this is the use of a wheel with an axle. And our best guess says that this was discovered by a potter of all people, approximately 6,000 years ago in Mesopotamia. And this is the first evidence that we had that anybody had realised that the centre of a spinning wheel or spinning disc is stationary. And if we mount that on an axle, it can continue to turn on a stationary spot. If that axle is actually mounted underneath the load, it means we can move the load without having this problem with the rollers of having to move them forward. Equally, it allows the wheels to turn at different speeds on different sides, getting around the problem that we had of friction. And many scholars actually consider the wheel to be the single greatest invention of mankind. As technology improved, new ways and materials were used to make wheels, and you can see some of this progress in the way car wheels are manufactured. Whilst in the past, both wooden wheels and wire-spoked wheels have been used on cars, and you can also find both carbon fibre and plastic wheels, most modern vehicles you're going to find either pressed steel wheels or aluminium alloy wheels. Steel wheels are easy to produce, they're relatively cheap, and they tend to be strong. But as a wheel building material, aluminium alloy does offer several advantages. And these include the lighter weight, better heat dissipation for the brakes, and the fact that they can actually be made to look a lot nicer, better aesthetics. Now when we look at a wheel, there are several dimensions that are important to the sizing and correct fitment of a wheel. And these include the width, the diameter, the wheel offset, the PCD or pitch circle diameter, and the centre bore. Looking at the wheel width to begin with, this is typically measured in inches. And that figure doesn't refer to the overall width of the wheel, it actually is a measurement that's taken between the flanges of the rim, as you can see here in the video clip. Quite often you're going to see this measurement followed by the letter J. And this is due to the shape of the wheel flange themselves, J being the correct shape for passenger cars. On alloy wheels, it's quite common to actually see the measurement cast into the back of the wheel. But on steel wheels, you'll typically find it stamped into the outer rim. And this is because steel wheels are made up of two pieces, and the same wheel centre may be used with different wheel widths. Next, let's have a look at the diameter of a wheel. Just like with the wheel width, this is measured in inches. And again, the actual diameter doesn't refer to the overall diameter of the wheel, it actually refers to the diameter of the wheel at the part where the actual tyre bead fits. Wheel offset is another important measurement that you'll hear a lot about. If you draw an imaginary line through the centre of the wheel width and measure between there and the mounting face of the wheel, that would be the wheel offset. And this is measured in millimetres. The offset on the steel wheel is stamped into the outer rim. In this case, 43.5mm positive offset. The ET, or Einpresstiefe, that's German for press depth, can be either positive, negative, or neutral. If the offset is positive, it means the mounting face is closer to the outside face of the wheel. If the offset is negative, it means that the mounting face is closer to the inside face of the wheel. And if it's neutral, zero offset, this will mean that it's dead in the middle, right on the centre line of the wheel. Now you'll find that most front-wheel drive cars use a positive offset, and negative offsets were used on some older rear-wheel drive vehicles. The PCD, or pitch circle diameter, is the spacing, the pitch of the mounting bolt holes, and we commonly see 4, 5 and 6 bolt patterns used on light vehicles. Lastly, we have the centre bore, and this centralises the wheel on the hub. Aftermarket wheels are usually manufactured with a large centre bore. Fitment rings are then used to actually size the centre bore to the correct size for the vehicle those wheels are going on. Now the centre bore is quite a tight fit on the hub, so it's quite important to use an anti-seize compound such as copper grease when mounting the wheel. This is especially important when dealing with aluminium alloy wheels. The aluminium alloy can actually corrode firmly onto the steel hub, causing a real problem when you need to get the wheel off. The cross-sectional shape of the wheel rim itself is actually very carefully designed, and there are a couple of features that I want to point out to you now. The first of these is the wheel well, and the wheel well is there to help fitting a tyre to the wheel in the first place. The well has to be there to allow us to get the actual tyre bead, the steel tyre bead, over the J section of the rim. And do keep this in mind, as it will help you when we look at fitting tyres in the workshop. The second feature I want to point out is the retaining or the safety hump, and this is there to keep the tyre bead in place when you're cornering, and it prevents sudden deflation of the tyre. The last thing that we are going to have a look at in this presentation is the Schrader valve, and that's the correct name for the car tyre valve. When used with the correct tools, Schrader valves open and close automatically. This allows us to put air into the tyre and remove air out of the tyre if the tyre is actually overinflated. In operation, a metal pin in the centre is depressed by the tyre inflation tool. This in turn pushes a rubber-filled cap off of its seat. This allows compressed air to enter the tyre and inflate it. It can of course also be used to deflate the tyre if the pressure is too high. Thanks for watching. Now complete the work associated with this presentation. And don't forget to click and subscribe for more great content.